little champs. Welcome to Tinkerly TV. For more details, contact below website. Hello little champs. Welcome to Tinkerly TV. For more details, contact below website. Hello little champs. Welcome to Tinkerly TV. For more details, contact below website.
Hello everyone. Welcome to Tinkerly's YouTube channel. So Mr. Zodo is with us and he is welcoming you all to the Tinkerly's YouTube channel. Hi, I'm Barbie and I'm back again. So you all might be very curious what the Barbie has brought up today, what the experiment, what project the Barbie has brought. So it's a Ohm's Law. So we have heard many a times about the Ohm's Law, and today in this webinar, we are going to see what is the Ohm's Law, and we have tried to simulate the same on the Tinkercad platform. So let me just show you the project. Okay, so I'll just click on the Start Simulation. So you can see the bulb is glowing and the voltage is 24.6, right? And here is one resistor value is there. Okay, so the resistance is 1K ohm and the bulb is glowing. Now, I'm just changing the voltage. You can see the current is also changing for, let's say, for 5 voltage. Okay, let's say the 5. For the 5, the current is 4.7 mm. If I change the resistor value, okay, now I will just going to change the resistance value. Let's say the resistance is 2K ohm. Now it will check it. So you see, when I increase the resistance value, the voltage is same, 5 volt, but the current is dropped. And you can see the color of the bulb also. It has been lowered down, right? So when we increase the resistance, the current value is decreasing, right? Also, it happens because of the resistance. So in the Ohm's law, we're going to see what's the relation between the voltage, the current, and the resistance, and what it's getting the impact. Okay, this all we are going to see in this. So see, at just 1 ohm, it's glowing red. If I'm not applying any resistor to this, the bulb is glowing so bright. If I apply 1, you can see the current is changing to 4.7 milliampere. If I'm changing to 2, it's again decreased the 2.4 milliampere. So what is the use of the resistance, what's the relationships, and how this Ohm's law work, we're all going to discuss in this webinar. So let's move and see what is the roadmap to the journey. So first we are going to see what is the circuit, right? And then we'll come to know what is the current, voltage, and resistance. And at the third, we are going to see the Ohm's law. And fourth, we are going to see the series and the parallel circuit. And finally, we are going to design some circuits on the Ohm's law, the series and the parallel, and we'll understand this whole concept. Okay, so let me tell you my story. So let's start. So we are at the first circuit. So, you know, one day my father was doing something on this kit. They have this, and some wire got out, and he was just soldering the wire, and then he was checking with the ammeter the value of the voltage and the current and so on. So I was just sitting next to him, and I was very curiously looking at what he's doing, and I was just checking how the soldering of the wire he is doing, and then he was checking the current and everything. There was a board of electron. So I asked what it is. He told me that it is a circuit, and I'm just fixing out the wire, and because of that, my things are not working properly. So I have to solder the wire so that my circuit becomes complete, and my things should work out. So I was more curious. I keep on asking and asking, what is circuit? So he told me that an electronic is composed of individual electronic components. There are various electronic components such as resistors, transistors, capacitors, inductors, diode, and these are connected by some conductive wires or traces through which the electric current can flow. So in this way, he told me, so I are more curious, please explain me with the simple terms. I'm not understanding. So he told me that the electronic circuit is what? It is a closed path. It is a closed path where it is connected with the wires, which is a conductive wires. Conductive wires means through which the current can pass. So the current which pass through it, and the things the electric current can flow, and so that your electrical components like your fan, your bulb can glow. So here you can see that closed wire, and this wire is a conductive wire, so that my bulb is glowing. So okay, I understood that. And so he told me to make a bigger circuits. We have various other electronical components such as resistors, transistors, capacitors. So they have some values, like transistors acting as a switch and capacitor for storing the values. The diodes are there. So like this, there are various electrical components that we are going to use it, right, for making an electric circuits through which the electric current can pass through it. So I decided to make first a circuit on a Tinkercad platform. So let's see how we can make a circuit on the Tinkercad platform. A simple circuit. So I will just click on circuit, and then I will click on create new circuit. Okay, so circuit means what? Will require some power wire. So I'm just taking this battery, okay, 1.5 volt battery, and I'm taking the LED. I'm just taking a simple LED. Now, generally how to connect it? Then my father told me there is a cathode that which you have to connect to the negative terminal. So I'm just connecting the cathode to the negative and anode to the positive. Okay, so what has happened here? These are my wires. These are my conducting wires. So the electric current is flowing. So I will just click on start simulation. And you can see the light is blinking. I will just stop, and again I will click on the start simulation so that you can see how the LED is blinking. See, the LED is blinking in this way. So the current is passing from this negative terminal and like this. So the current is passing through the conducting wires, and which is helping my LED to blink. This is what a simple circuit, a closed circuit. Now, what will happen if we don't connect it? I'm not just connected one wire. I have not connected the other wire. You can see my LED is not blinking because it is not a closed path, because the current has to flow in a closed path so that your is blinking. The current is passing, but it is not reaching up till here and not coming back. So the path is not closed, and it is the things are not working. Now, what will happen if I just interchange the wire? I will just connect the cathode to the positive terminal and the anode to the negative terminal. And just click on start simulation and check. Still the LED is not blinking. So the connection should be also a proper, so that the circuit should be proper, where the wire has to be connected. All this should be proper so that the flow of current should be there and the LED should blink. So this was all about the Ohm's law. You can see this is the cathode. Okay, and the cathode, the current flows from the cathode to the anode, and that's where the bulb is able to connect. So this is how we have seen right now also in this, that the cathode, from the cathode, the bulb will glow. Just I will do the connections in a proper way. and click on the start simulation. You can see the LED is blinking. So it is going from the negative, that is a cathode, and the flow of current is in this way. So this is a simple circuit. Okay, now let's move. So we understood what the circuit is a closed path, so that the flow of current is there. Now, what is that current? So we are at the second stop: current, voltage, and resistance. So what it is? What is a current? What is a voltage? And what is a resistance? How this is? So first we have to understand what is a current. We always heard about this word. I once, what happened? My hand was little wet, and I just accidentally touch some wire, and I get an electric shock. Then my mother said, it's a current, you got a current shock. So I was like, what's the current is all about? So the current means something which passing through that wire, right? That's why when my hand got touched, I got an electric shock. So what is that? What is passing through this wire? So through the passing through the wire is the electrons. So current is what? Actually, it is the rate at which the electrons flows past a point in a complete circuit. Complete circuits, there is a flow of electrons, right? We discussed already the electrons flow from the negative towards the positive. So it likes from the cathode to the anode. Here we can say from the negative points to the relatively positive points. So the current is the rate at which the electrons flow past a point in a complete circuit. The rate at which the current electrons are flowing, that is known as the current. So the electrons are most common charge carriers and are negatively charged particles. So we already know the electrons are what? The electrons are the negatively charged particles which flow in a circuit. Okay, so and they flow from the negative to the positive charged particles. Now, what is a current? Current measured in a ampere. That is, I is a symbol and it is measured in an ampere. So the rate at which the electron moving, that is measured in a ampere, and it is the current is indicated by the symbol I. Okay, so this is all about the current. So in a wire, so if it is a conducting wire, conducting which allows the electrons to move it, that is known as a conducting. Some are the insulators, some are the semiconductors. So insulators are what? Which doesn't allow the electrons to move. They don't allow the passing of that, like wood, rubber. These are the examples of the insulators, which doesn't allow the graphite, which doesn't allow the electrons to move, the electric current to pass. Whereas the conductors, the conducting wires, which allows it. For example, I get a shock. So, but obvious my body is there. So my body allows, why? Because it is made up of water, right? Our body is 90% is made up of water, and water is a good conductor, which allows the electrons, which allows the electric current to pass through it. That's why our body also pass the electric current. Apart from that, we know the wires like the copper wires and all, aluminum wires, copper wires. These are the examples of the current, the conducting wires. Apart from that, the gold, silver, this all allows the current to pass through it. Okay, so the current is measured in ampere and it is indicated by ampere A. Now, what is voltage? If we understood the current is a flow of electron. So what is the voltage? Voltage describes the pressure, the push of the electricity. The amount of voltage is indicated by unit known as a volt, V. Okay, and higher the voltage, more electricity to flow to the electronic device. So what is happening? Voltage is what? A pressure. The pressure with which the electrons will move. So someone is like pushing us, right? If you want to run, someone like is pushing us. So the voltage is acting as the same. It is a pressure. Go pushing the electrons to move so that the current will flow. So this happens in the electronic circuit. So what will be the pressure? With how much pressure? So that is measured in a volt. Okay, that amount is measured in as known as a voltage, and that is measured in a volt. So we might have heard about the voltage, right? We say that iron is 1,000 volt, our iron, then our the devices, the batteries, that is a 9 volt battery, means this 9 volt battery means the voltage across that battery is 9 volt, which allows the current that's 9 volt, and then depending upon that the current will flow. Okay, the electrons will move. So this is all about the current and the voltage. Now I just went once to a waterfall. Okay, recently I went. So there what happened, what the water generally flows from high level to the it doesn't water will not flow not coming from the one side to the other side when they're at the same level. The water generally flows from the higher level to the lower level. That we have seen and that we understood when I had visited to a waterfall. I see the water was flowing from a from the very height to down. So similarly here also see that where the water will flow from A to B, it's not like the water will flow from A, because here the water will not flow, it will be steady. There's no difference in the height. So this same applies in the electric current. Electricity acts similarly. The concept of water height is analogous to electric potential. Means the electricity flow from from the places with high electric potential to the low electric potential. So electricity also acting as the same. So what happened, my water is I was using the pipe. Okay, so what happened, the flow of water from the pipe was too much. Okay, it was so much that within a second my bucket was filled with water, and it was the pressure was also very high. So what happened, I just wanted to lower down because of so much water the bucket filled, and the water was flowing. Even the nearby the small plants, they died because the pressure of water was so much and they cannot handle that. So what happened, I used the knob, okay, and I lower down the water. So when I lower down the level, I use so the water coming from the pipe also lower down. And then the bucket filled very slowly, with not, the water was not coming with a pressure. So water filled very slowly, and the nearby plant also required amount of the water. It's not like they get the over water and the plant died because of that. They get the advocate. So this, I understood the concept that the flow, the resistance was there to the flow of water. So now the same thing happened with me. Okay, the same thing when I was using the current, the same thing happened with me. So I just wanted to show you what happened actually with me. Okay, so let me go to the circuit and I will show you the same. This will only I will open. Okay, so I just take 1.5 volt was okay, sufficient. My LED was blinking. So now I took the 9 volt battery. Okay, and I just connected my this. So the cathode is always connected to the negative, just and this. And when I click on the start simulation, you can see my LED got burst. Okay, because the current was too much. Here the LED is glowing, but here the LED got burst because the current passing is too much, and they are telling the current required is just 20 milliampere, and it is like three times not, 4 times more, and in fact 5 times more current is passing. So the LED got burst, and I understood the concept the same that this water one, right? Because we understood that the water high, the current is also flowing from the high potential to the low potential. So the year also I experienced, I told you the water was coming so much, so I applied the knob and the resistance I have did. So some resistance we have to apply to the current as well, because you have seen that my LED got burst. What is the electrical resistance? So electrical resistance is the force that counteracts the flow of current, which doesn't allow the current to pass so much. Now you have seen there was a 915 milliampere. Just my LED required 20 milliampere. The current was passing 5 times more, approx. So I have to provide some knob, some resistance, so that the maximum current should not flow and my LED should not get damaged. So the resistance is there. So what is that? When an electronical difference exists between two terminals, the electricity will flow from high to low, right? We already understood it, that the same like a water, it will flow from high to low. So resistance counteracts that flow. It will lower down that flow. It will give resistance. The greater the resistance, the lower the current. So if we give so much resistance, the current will be low down, and it is measured symbol ohms. So the ohm, this symbol is known as a ohm, which measure how much resistance we are providing. So like voltage is measured in volt, the current is measured in ampere. So the resistance in the circuit is measured in the ohm. It's a SI unit and it is measured in the ohms. Now, just we are relating with the waterfall and the water, that the water flows from the high level to the low level, and we provide the knob, the resistance, right? So we have also the how much resistance to provide. It is measured with the ohms, means how much value of the resistance to be provided so that our circuit should work properly. That is done with the resistance, right? So that value of the resistance is measured in ohms. So how this ohms comes and how we can calculate. So that's why we are at the third stop, that is a Ohm's law. So the Ohm's law, this is a George Simon Ohms who states this law and who told that the voltage across a conductor is directly proportional to the current flowing through it. Okay, so the greater the voltage, the greater the resistance, the greater the current. Just we now see that it was 1.5 volt, the current was okay, and our LED was blinking perfectly. But as soon as I gave the 9 volt, the current was 915 milliampere, and it was a too much current, right? So the Ohm's law stating that the voltage across the conductor is directly proportional to the current flowing through it. So provided all the physical condition and the temperature remains a constant. So that is why we have seen that voltage increases, the current increases. So too much current damages our components. So for that, we have to understand the resistance. So here the Ohm's law has given us the formula that V is equals to IR. Means when the voltage is increasing, the current will also increase, but there will be some resistance, means some suppression, so that the current flow, it should not exceed too much and it should not damage our component. So this is how the Ohm's law told us. Now this is the way the Ohm's law look like. Just now what we have seen, we just connected the battery and the bulb. So the Ohm's law here is like you have a battery. This is the measuring of the current, and this is a voltage. In between, we have used some resistance. So we have applied some resistance so that we can manage, we can see the voltage and the current by using the V is equals to IR. So with the help of resistance, our providing some resistance, our component shouldn't get damaged. If the we have seen that it at our home also, the current coming, the voltage is similar. Okay, it is not like the fan is moving with some other voltage, so we will provide the voltage there. No, our home is getting the same volt. So the components then we have to change. In that fan, we are using the resistor. The iron and heater require the more resistance, right? Because the current passing is same. The voltage is so much, the 1000 volt, the what we say our microwaves and all require the high voltage. So the resistance for them, it's we have to give it so that the components won't get damaged. So for that, how to provide the resistance? For that, we have the electrical components known as the resistor. Okay, so the resistor is a passive two-terminal electrical components that implements electrical resistance to a circuit element. So resistor here, which is an electrical component, which is providing a resistance to your component. So let me first show you how the resistance is working, and then we will see what will be the value, how we'll come to know which resistance, which ohm resistance we have to apply. So let's see first this. So we were here, you have seen that the current is passing too much. I will just stop the simulation and I will use the resistor. Okay, so I will just going to use the resistor. See, I'm using the resistor. Okay, so what I have did the cathode, I have the negative terminal, but anode, I'm just connecting one terminal of the resistor with the anode and another terminal of the resistor with the positive of the battery, right? What I have done, I've taken the resistor has the terminal 2 and terminal 1. So one terminal I have connected with the anode of the LED, and other terminal I have connected to the positive terminal of the battery. Now we'll click on the start simulation. Now we see that the LED is blinking perfectly fine. Now what will be the resistance value? It is told that here it is 1 k ohms. 1 k ohm. See, you can see the Ohm's law. There are various ohm, k ohm. So we have used the 1 k ohm. You can see the color of the resistance as well, resistor as well. This is brown, black, and red. If I change, it's a 440 ohm. So you can see 440 ohms, I'm telling. So 4, that's why it is a 2 are thus. And when I click on the start simulation, my LED is blinking, right? The current is okay, 440 ohm. Now, if I just reduce the value, if it is, I'm not providing the resistance, it is, you can see it is broad burst. If I'm using 220, what is telling? 220 resistance I have provided. 220 means this red, brown. You can see the color. But what it is telling, the current through the LED is 30.9 milliampere. Means some current is passing, but that is too much. For the LED also, that is a too much, but okay, it is bearable. Maximum is 20. So you can see the resistance value. We can check it with the help of voltage, the resistance value, and the current. So this is what our Ohm's law has told us, that V is equal to I. So V is 9, I is somewhat 30 milliampere into 220 ohms, that is a voltage, that is a resistance, multiplied by this equal to 9 volt. So this all has been calculated. So what is this resistor value? That we'll discuss it, how we to calculate, what are this different colors is coming on this stripes, and depending upon the voltage, resistors can be used. So the resistor is providing the resistance. Now just come back with our same example. The water flows from the high level to the low level. So from there we use the knob, right? So low down the water flow, the pressure of the water. So here in this electrical circuit, the resistance is acting as a suppressions, yeah, which doesn't allow the flow of current so much, right? So with this help of resistance, circuit, our components have not got damaged. Our earlier the LED was got damaged. Now the LED is not got damaged. We can change the value and understand the concept. Okay, so this was all about the resistance. So you can see the resistor. This is a color table for the resistor. This is the first digit. This is the second digit. This is the third. This is a multiplier with the ohms, and this is a tolerance, means how much the tolerance. Now, for example, 220, right? We require 220 ohms. So this was the red, right? So 2 red. This was the color red. This was the color red, and you can see that was a brown. So 220 ohms. Well, again, I will go back and told you that we have used the 220. So 220 means this was the red color, this was the red, and this was the brown. So we come to know this is a 2. So yes, we have to learn this chart if you want to know the color of the resistance and how much ohms it is. It can be easily learned. Now here, for example, 62. 62 means what? Violet. So that's why it is a violet color. 2 means red. So see, it is a red. And just ohm. So that's why it is a black, right? If it is 620, then it would be have the brown color strip. So we come to know brown 220. 1K. 1K, see, 1K means 1 ohm. So this is the value of 1K. So 1K means 0, 0, 0, and 1. So just we'll go back and check. We were here, right? See, 220. So it was like red, and the brown. Now, if we are using 1K, see, you can see the, right? If it is like 62 ohms, that we have seen it on our, see, if it is K ohm, that is orange something. If it is a ohm, so it is a black. See, violet, red, and the black. So this is a 6, the first line. This is the red line, which is on the 2, and this is a black. So we come to know this is a just ohm. If it is, we are changing it to K ohm, so you can see the brown color, orange color. So like this, the resistance value keep on changing, and we can see this through this chart, and we have to learn this. See, it was a like orange color 1K ohm. So 6 was this, and 2 was red, and this was K. So this is how we can come to know the resistance value, resistor value in the ohms. So this strips, this color tables, this stripes on the resistors help us to find out what is the value of the resistance in ohms, whether it is a 1 ohm, 10 ohms, 100 ohms, or K ohms, like this, it is able to understand. So this resistor, we are going to use it. Now, what is the applications of the Ohm's law? In a real life, how we are using it? What's the purpose? Why this value of the voltage and current and the resistance are interrelated? What's the use? So it is telling that shifting the regulators to and fro, right? To and fro. We can regulate the speed of fans in our house. We know it. We already discussed. Okay, there was a knob. The pressure flowing from the pipe was controlled with the help of the knob, right? So here also the flow, the voltage is similar for all the electrical appliances. So how we regulate the speed? We regulate with the help of regulator, and in that regulator we have a resistance. So when we change the speed, the resistance will also change, and it will make the speed of the fan high or low. Similarly, your electrical heater have a high resistance metal coil, right? Our heaters has a coil, metal coil, so which allows a certain amount of current to pass through them. So your heat will be heated. So that component is measured with the resistor. right? The 220 volt is applying. So what will be the, how the resistance will be there, that is there in your electrical component. So your electrical component won't damage. Similarly, your electric kettle, iron, this all have the resistance which regulates the um, heating effect or passing of the current and the voltage, because the voltage is same from at the house. Even your mobile and laptop charger, which converts it into the DC supply. So your components like your electric, your phone, your laptop is not damaging, because your phone, mobile phone, and the laptop charger has a resistance which follows the Ohm's law. So how much current is coming, so how much resistance should be there to give this required amount of current. So all this is calculated by the Ohm's law. Even the fuse at our home, sometimes too much volt current is passing, the fuse up, right? We says the fused out, and then we check the fuse, because the resistance is unable to tolerate the so much of voltage and the current. So these fuses are used at our homes also, so that it won't damages our appliances. And generally the application of the Ohm's law is that it is used to maintain the desired voltage drop across the electronic component. So this is what will be the voltage drop around the component, that all can be calculated using the Ohm's law. So this was all about the Ohm's law. So now we resistors are there and we have to apply the resistor. So how we can apply? The resistor can be applied in a parallel and can be applied in a series. So we are at the first stop to understand that what is parallel circuit and what is series circuit. So let's see what is series circuit is. So when the resistor are placed in a series with each other, the current flow through each resistor is the same. Okay, when they are connected in a series, the current flowing is the same through each resistor. And how will you calculate the total resistance? So the total resistance of the circuit, you can just add up the resistance to each resistor. So by adding the resistor, we can get the total resistance. And the total voltage of the circuit can also be found out by adding up the voltage across the individual resistor. So there will be individual resistor and we have to calculate. So for example, we are using 1K ohm, and here we are using. So the voltage across the 1K ohm will be calculated. Voltage across the 2K ohm will be calculated, and that voltage across 1K ohm plus voltage across 2K ohm will be added, and that will be the total voltage across the series circuit. So this is calculated using the Ohm's law. So this is how, so resistor is adding up. Okay, so resistors are adding up means the current will flow down. Okay, and the voltage has to be individually calculated and add up the voltage. Okay, so this is all about the series. In a parallel circuit, the resistors are placed in parallel, okay, one by one next to each other. So how we calculate the total resistor? So we inverse it, we reciprocate the total resistance of the circuit, and then we add the inverse of the all the resistor. The current, when the resistor is adding, resistor is decreasing because it is inverse. Okay, in a parallel, we do the reciprocal and we add it. So the resistance is decreasing in the parallel circuit, where then the current will increase. Okay, and then the current will be added. How the current will be added? That what is the resistance? The voltage here uh, is same across everywhere. Okay, the voltage across every resistance is same in a parallel circuit. So how the current is calculated? The current is calculated across, for example, 1K ohm resistance is there. So the current is calculated across 1K ohm because the voltage is same. Similarly, the current is calculated across the 2K ohm, the voltage is same, and we are adding up both the current and we are getting the desired current. So let me just give you again, explain you the series and the parallel. So this grammatical, which can easily understand to you. So you can see the current passing is same. Okay, the current passing is in a parallel circuit is different. The voltage is same. This is a parallel circuit. So how we calculate the resistor? 1 by R. I told you the reciprocal. That is 1 by R1 plus 1 by R2. So current is also calculated according to the resistor R1. That will be I1. And the current to the R2 resistance will be I2. The voltage is same. Then we add this I1 and I2, we get the total current. In a parallel circuit, we told, in a parallel circuit, the voltage is common. Whereas in a series circuit, the current is same, but the voltage is varying. So in a parallel circuit, the current is varying across each resistor. In a series, the voltage is varying across each resistor. In a parallel, the voltage is same. In a series, the current is same, right? So see, the current is same. The resistors, the voltage is calculated across the resistor R1 is by V1, and the voltage across the resistor R2 is V2. Now we can add this and we get the total voltage, and resistors R1 plus R2. So this is all about the series and the parallel circuit. The resistance are in a parallel, the resistance are connected in a parallel, and we calculate with the help of reciprocal of the resistors. Here the current will increase. Here the current will be calculated for each individual resistor. The current will be different for different resistor, and then we can add up the current. The but the voltage will be same in the parallel. Okay, so this is all about the parallel circuit. Yes, and in a parallel circuit, the current will increase because the resistance is decreasing in a parallel. Now, in a series, the resistors are connected in a series next to next. The voltage across each resistor will be different and will be calculated with the help of Ohm's law. And we have to add the resistor, add the voltage to get the desired voltage, how much voltage, and the resistor is also being added. All right, the current passing through the series is the same. Clear? This is all about the parallel and the series circuit. Yes, is it interesting? Now we have understood all the theoretical concept about Ohm's law. What is a resistor? What is this? What happens when we connect the resistors in a parallel? What happens when we connect the resistor in a series? Now we are at the first step to design the circuit. So we are using the Tinkercad platform. Yes, we have seen so many circuits, and we are going to use the Tinkercad platform to have the this all circuit design. So let me just go one by one with all the things. Let me click on create new circuits. So we just understood with the concept of the circuit, right? And what is the use of the resistor, how this resistor values are changing. Now we'll come to know and we'll understand with the help of Ohm's law. So for the Ohm's law, what I'm doing, I will just take the bulb. Yeah, first we'll go with the basic of the power supply and the resistor. Okay, this I have taken. And the resistor. Okay, so this is a simple I'm taking. I'm not taking any bulb. Here the power supply, you can see there is a voltage and the current is 5. You can see this is a voltage and the current, and I'm just checking the resistor. One terminal I'm connecting and another terminal I'm connecting to this. Okay, so I have used which resistor? 1K ohm. Okay, I will just click on the start simulation. You will see when the current is, when the voltage is 5 volt, the current passing is 5 millivolt for the resistance 1K ohm. Now, if I increase the resistance to 2, so what will happen? you can see the current is decreased, right? Because we have given a lot of resistance to it. We have provided the resistance of 2k ohms, so the current is decreased. Now, if it is 1k, the current is 5. It is increased. So we understood V is equals to IR. V is equals to IR. I is 5, R 1. So 5 into 1 equals to 5 volt, right? So this is how we understood the Ohm's law. So the resistance, the voltage V is equals to I and the R. What will be the value of resistance and milliampere? Not 2k ohm. So what happened? Decreased. Why? V is equals to 5R. So 5R. So what will be 5 equal? V is equals to 5. And what is the current? 2.5 into 2. We get the 5. So V is equals to IR. That is the Ohm's law is getting correct, right? So if we are applying the too much of resistance, the current is decreasing, but the voltage will be the same. So we are multiplying the current into the voltage, current into the resistor, the voltage we are getting, right? So if the resistance is 1, the voltage will be 5. If the resistance is 3, it is 1.67. So if we multiply 1.67 into 3, we will get the 5 volt. So this is V, that is voltage, is equals to I, that is the current, that is into R. R is a resistance. So V is equals to IR, that is a milliampere. Ampere is a unit, and resistance R is a ohms. So this is basic about Ohm's law. Now what we'll do, we'll just make it as 1 only, and now we'll connect it in a series. Series means, just see, what is a series? The resistance are connected in this manner, next to next each other. Okay. So what we have to do, we have to connect it in a series. So what will happen if we are connecting in a series? You can connect it like this. The one terminal is connected over here, terminal is connected over here, and this terminal is will go here. So what is the current? 5 volt. And what happened to the current? 2. When we are using only 1K, the current was 5. When we connected in the series, what happened? The resistance are added, right? We have discussed that in a series, the resistance are added. So here this is a 1 plus 1, 2. So 2k ohm resistance is applied. So 2 into 2.5, it is a 5. So this is how in a series it is. Now, if we are using the 3, we know 1.67 when we increase the value. Now, if we connect it in a series, right? The resistance are connected in a series. So there is a 3k ohm resistance and the current is 1.6 milliampere. This was all about when the 5 volt is there. The current is same. Now, if we increase from 5 volt to 10 volt, so what will happen? Our current is also increased because the voltage we are applying too much, but we have used the 3 resistance. So 3.33 into 3 will get 10 ohms, 10 volt. Okay, so this is how it will work in a series. Now I will just remove this, all the resistance over here, and we'll understand. Now only just 1K. So now we'll calculate 10, and this will be, what will be the current? 10 milliampere. Let's check whether it is coming 10 milliampere. Yes, it is coming 10 milliampere. Now if we change the value, resistance to 2, it will be half. 5 into 2, 10. So it will be, the current will be 2. So this is all about the Ohm's law, and we have seen in the series. Now we have to connect it in a parallel. So I will first take 2 in a parallel, we'll connect it. See. right? We have seen how the parallel connections look like. The resistors are connected in a parallel, next to each other. So let's see, the current, the voltage is 10V. What will be the current? The current is 15 milliampere. So because the resistance, when we connect in a when we connect it in a parallel, the resistance value is decreasing. It is not adding up. It is the reciprocal and then adding, and the current is 15 milliampere. So current has increased when we connect it in a parallel. So that's what we have discussed, that in a parallel circuit, the resistance value decreases because we reciprocal it and do that. But when we connect it in a series, the resistance are adding up and providing the lot of resistance. So the value decreases. So when to use the series, when to use the parallel, depending upon our electrical components, how we want it and what the resistor. So depending upon that, we connect it to the series and the parallel. Now we'll just reduce it to 5 volt. If it is 5 volt, what will be the current? I think so, 10. 7.5, right? 7.5. If we are connecting it to the 5 volt, the current will be 5 volt. $7.54 milliampere. So the current. Now, if we are connecting one more in a series, this we have connected in a series. Just check the voltage and the current. Okay, so this was all about the connections in the series, connections in the parallel. Now we'll do it with our bulb. This you have shown these two are connected in a parallel, in a series. These two are connected in a series, and this two is connected in a parallel. So it was all the misconnections. You can see the value of the current. So this twos are in a parallel and this two are in a series. So the value of the current has been changed. Now, this was all about the series and the parallel connections. Now we'll use the light bulb and check it. However, what happens to our light? Just we'll keep it aside. Okay, and we'll take the light bulb. And we'll see how the components means actual effect on the components we can see. Light bulb, okay. We take that. Okay, so we are providing one resistor, just first without resistor. So we'll see what happens without resistance. So the 5 volt, the current is 104 milliampere and it is glowing very bright. It's glowing very bright. Now we'll use some resistance in between. Instead of that, I will just delete it and use the resistance. And if when I use the resistance, it is 2.4 milliampere. The resistance is 2K ohms. And you can see the bulb is not glowing as bright as it was glowing earlier. So the resistance is too much. The current is very low down. Just 2K ohm, the resistance, the current was very low down. I will just, instead of that, I will use 1. Still, the bulb is not glowing bright. Now, if we increase the voltage, let's see, increasing the voltage. You can see it is little brightening up. See, wow, with the 30, it's brighten up. And just if I reduce it, you can see how it is. See, it was 5 volt, right? How it was blinking. So that also the Ohm's law help us to calculate it. Now instead of 1K, I'm just using 220 ohms. Okay, so see, it has brightened up more. And if we are increasing, the F is increase the voltage, the bulb is glowing, even the current is in this. So we can connect it in a series, we can connect it in a parallel in the same way. Now, if you want to connect it in a series, what will happen? The resistance will add up, right? So see, this is a 1K. Okay, and the 9.3. Earlier it was going very bright. Now, if we apply the 220, not K ohms, ohms. So you can see the resistance has been added and the current has been changed. The value of the current has been changed. You can see this is connected in a series. Now, similarly, when we connect it in a parallel, what happened? Oh my God. The current has been increased and it is going very brightly on the same voltage. So this was all about the Ohm's law, connection in a series, connection in a parallel, when to use, how to use. So what we have taken away from this journey, we understood what a circuit is all about, the closed path, the flow of electrons, and how the bulb will glow. So we understood the current. Current is the flow of electrons. It is measured in ampere, the voltage, the force with which electrons will move, and the resistance which suppress the flow of electrons, means the speed, that is known as the resistance. Then we understood the relations between this all three with the help of Ohm's law. It is V is equals to IR. Now we understood what is happened with the connection in the series and the parallel circuit. Equals to IR. What happened when we connect it in a series and what happens when we connect it in a parallel? So in a series, the resistance value is decreasing and the current value is decreasing. Whereas in a parallel, the resistance value is decreased and the current value is increased. And how we calculate it? All that we have seen, that in a series, the resistance are calculated by adding the resistance. In a parallel, we reciprocal it, inverse it, and then we add it. So the resistance value decreases. So this was all about for the today's webinar. So it's me now, Barbie. I'm just signing off. Stay tuned. Bye-bye. Take care. Thank you.
Hello. I am back again. Thanks for watching Tinkerly TV. Subscribe us. Contact to below site for more details and queries. Hello. I am back again. Thanks for watching Tinkerly TV. Subscribe us. Contact to below site for more details and queries. Hello. I am back again. Thanks for watching Tinkerly TV. Subscribe us. Contact to below site for more details and queries.